AUTOSAR questions and answers. AUTOSAR question and answers. What is AUTOSAR and why it is important in automotive software development? AUTOSAR, Automotive Open System Architecture. It is a standardized software architecture used in automotive industry for developing and integrating the electronic control units. It enables the modelization, reuse, and scalability of the software across different hardware platforms. Its importance lies in ensuring the interoperability, reducing development time, and improve the safety and quality of the automotive software. What is the difference between AUTOSAR Classic Adaptive Platform? AUTOSAR Classic, it focuses on embedded system with real-time requirements, often used in safety critical system like engine control and braking and airbags. AUTOSAR Adaptive, it designed for more complex, high-performance ECUs, supporting the high-level functions like advanced driver assistance system, infotainment, autonomous driving. Can you explain the different layers in AUTOSAR architecture? The AUTOSAR architecture is divided into several layers. The application layer, it contains the software component, SWC, that implement the application specific functionality such as sensor processing or motor control. Runtime environment, RTE, act as the middleware that enables the communication between SWC and basic software. Basic software, BSWC, provides the hardware abstraction, essential services, operating system, communication, diagnostics. It includes the service layer, provides the OS and diagnostic communication services. ECU abstraction layer, abstract the hardware specific detail for external devices. MCAL is the microcontroller abstraction layer. It directly interfaces with the microcontroller peripherals. And complex device driver, CDD, it is used for non-standard and time-critical functionalities. What are the key components of basic software, BSW in the AUTOSAR? The basic software BSW is divided into three main subfunction layers, service layers. It includes the operating system, communication services, scan, listen, and diagnostic services. ECU abstraction layer, it provides the access from the higher layers. Microcontroller abstraction layer, MCAL, it is directly interfaced with the microcontroller, internal peripherals such as ADC, GPIOs, and communication modules. What is the role of the runtime environment, RTE in AUTOSAR? The runtime environment, RTE, is a middleware layer that connects the application layer, SWC, to the basic software. It abstracts the software components from hardware and lower layers, enabling them to communicate without being aware of the hardware specific. It handles the scheduling, task synchronization, and event handling, allowing a SW to focus on functionality without worrying about underlying hardware configuration. What are the ports in AUTOSAR? Ports in AUTOSAR are communication endpoint that enable the software components to exchange data. They define the way data flow between different SWCs and external interfaces. Ports are classified into RP port, received port, used to receive the data, PP port, provider port, it is used to send the data. What is the role of the sender and receiver interface in AUTOSAR? The SR interface defines the structure of data exchange between components using sender and receiver communication. It allows provider port, PP port to send the data to multiple receive port, RP port asynchronously. What is the difference between the required port and provider port in AUTOSAR? Required port is the R port. It is used by the software component to receive information and services from other SWE. Provider port, P port, is used by a SWC to provide the information or services to the other SWCs. These ports facilitate communication between different SWCs in the system and help them how data is exchanged between them. What are the types of ports in AUTOSAR? There are two main types of ports in AUTOSAR. Sender receiver port, it is used for data communication between STWC, and one provider port sends the data, and multiple receivers RP port can receive the data. Client server port, CS port, it is used for service based communication. The client port sends a request and service port processes it and send back to the response. What are the different types of communications used in AUTOSAR? AUTOSAR defines the following types of interfaces for communication. Sender receiver port interface, it defines the structure of data exchange. Client server interface, it defines the service based communication. Module switch interface, it defines the communication for mode exchange. Trigger interface, it is used for event based activation of SWC. NV data exchange is used to manage the non-volatile data storage and retrieval. What are the different types of interfaces in AUTOSAR? AUTOSAR supports multiple communication mechanisms, include sender-receiver communication, is used to send the data from one component to another, typically used for periodic and continuous data exchange. Client-server communication is used for requesting a service or data, commonly used in diagnostics and control request scenario. SWC communication, it facilitates through the RTE and involve communication between the SWCs in a ECU across the multiple ECUs. What is the role of CDD in AUTOSAR? CDD is a complex device drivers is used when there is a need for non-standard and time-critical functionality that cannot be handled by the standard AUTOSAR module. The drivers are highly dependent on the hardware, are typically used for controlling the specific devices and peripherals that require precise timing and precise handling. CDD provides the direct communication between the microcontroller and the application layer, bypassing the standard abstraction layer. How does the microcontroller abstraction layer work in AUTOSAR? MCAL is a layer in the base software that provides abstraction of the microcontroller hardware to the upper layer of the software stack. It allows the application and ECU abstraction layer to interact with the microcontroller internal peripherals such as a timer, ADC, communication module without needing to know the specific hardware detail. MCAL simplifies that development process by the abstracting the microcontroller's hardware from the higher layer. What is the difference between internal devices and external drivers in the AUTOSAR? Internal drivers, the drivers are used to access the internal peripherals of the microcontroller, such as the EEPROM, ADC. They are typically a part of the MCAL layer. External drivers are used to access the external peripherals like EEPROM, flash memory, sensor located outside the microcontroller. External devices usually reside in the ECU abstraction layer, but can sometimes be a part of MCAL if the device is directly memory mapped. Can you explain the concept of ECU in AUTOSAR? An ECU is a physical embedded system responsible for controlling one or more functions in a vehicle. In AUTOSAR, ECUs can be run multiple software components that implement various vehicle functions like engine control, braking, and infotainment. AUTOSAR standardizes the software architecture to allow the component to run independently of the ECU's hardware configuration, enabling easy software portability across the different ECUs. What is the purpose of ECU configuration tool in AUTOSAR? The ECU configuration tool is used to configure the software component and the base software layer according to the ECU hardware configuration. It generates the necessary code to create the RTE, configure the ports, initialize the MCAL. The tool helps in defining the software architecture, ensuring that all components and service interact properly according to the AUTOSAR standard. What is the role of managers in AUTOSAR? In AUTOSAR, a manager is a software module that provides the services to the multiple clients. It is used when a single handler is insufficient, especially for managing the shared resources or services that require coordination across the multiple clients. For example, NVRAM manager controls access to the flash memory, ensuring that multiple clients can safely access the memory without conflict. What is the functions of the service layers in the base software? The service layer in the basic software provides the high-level services to the application layer, other part of BSW. The services includes operating system services such as task manager, scheduling, and time management that will be handled by the OS. Communication services provides protocols like CAN, LIN, FlexRay, Ethernet, and more. Diagnostic services include diagnostic communication management and fault detection. Memory services, it is a management of the volatile and non-volatile memories, NVRAM, EEPROM, and flash memories. Security services, encryption, description, and authentication. These services ensures that software components in the application layers can operate independently of the hardware detail and facilitate the software reuse and abstraction. How does AUTOSAR architecture handles timing and synchronization between the software component? AUTOSAR handles timing and synchronization between the software components through the runtime environment and the operating system in the BSW software. The key accepts includes RTE. It manages the communication and synchronization between the SWC and ensure that the events and the data are properly handled across the different software components. It supports synchronous and asynchronous communication. OS in the BSW ensures that time constraints are met by the scheduling task according to the system timing requirement. The OS can handle multiple tasks, including periodic tasks with fixed time interval for real-time application. AUTOSAR also supports mechanism for time-triggered communication, sender-receiver interface to synchronize tasks, and data exchange between SWCs. What is the purpose of ECU abstraction layer in AUTOSAR? The ECU abstraction layer provides the interface between the application software and the microcontroller hardware, abstracting the complexity of accessing and controlling the external devices. It simplifies the access to devices by offering a higher level interface that enabling the application layer other part of the system to be the independent of the hardware specific configuration details. Examples of services provided by ECU abstraction layer includes communication protocol, CAN LIN Ethernet, external memory management, EEPROM and flash, IO operation for sensors and actuators, power management and external hardware control. How does AUTOSAR handle communication between different ECUs? AUTOSAR handles the communication between different ECUs by using the standard communication protocols like CAN, LIN, AUTOSAR, FlexRay, and Ethernet. The communication services in the services layers of the base software that provides the necessary services to facilitate the communication across the ECUs. The communication is typically divided into two categories. ECU communication. It occurs between the different issues and it manages using the communication stack that includes the protocols as a CAN, LIN, FlexRay. And in the intra-ECU communication, it happens between the SWC within a single ECU. It uses a runtime environment to facilitate the transfer of data between the SWC in the same ECUs. And this communication mechanism ensures that ECU and SWC are exchange the data and maintain synchronization and coordinate the operation across the vehicle. What is the role of the port in AUTOSAR? How do they facilitate the communication? In AUTOSAR, ports are the interfaces that which the software components communicate with each other. They represent the point of interaction between the different SWCs, between a SWC and the basic software. There are two types of ports. Provider port, P port, is used by an SWC to provide services or data to the SWC. It exposes the functionality of the SWC to other component. Required port, R port, is used by SWC to request a service or data from the other SWC. It is a point where the SWC receives input from the other SWC or a component. Ports allows for data and control information to flow between the components, ensuring that modularity and reusability of the software across different hardware platforms. What are the advantages of using AUTOSAR for developing the automotive software? Some of the main advantages of using AUTOSAR for automotive software development includes modularity. AUTOSAR layered architecture allows for modular approach, making it easy to develop and test and maintain the individual component. Portability. Software components are independent of the hardware, allowing them to reuse across different ECUs and platforms. Scalability. AUTOSAR supports a wide range of ECUs from simple embedded controller to high performance system used in ADAS driving assistance system, ADAS. Standardized in AUTOSAR standard provide a unified framework for automotive software, improve the interoperability between the different suppliers and vendors. Safety and reliability. AUTOSAR provides a safety-focused development framework, particularly in critical systems such as engine control or brake, are ensuring that high level of reliability and fault tolerance. tolerance. How does AUTOSAR supports a real-time and safety critical system? So AUTOSAR supports a real-time and safety critical system through the real-time operating system AUTOS and soft safety layers. Key feature includes real-time operating system AUTOS. So here mainly the focus is about it includes the scheduling of the task, allowing of the multiple users to access the same data, and it is a time constraint, and periodic tasks with a strict timing requirements can be accessed here. And safety feature, it includes provides the mechanism for implementing the functional safety standards ISO 262, and moreover, this can be accessed uh, the fault detection and error handling, and the redundancy and system diagnostics, and to ensure that safety criticality system can be operated reliably. What is the purpose of microcontroller abstraction layer, MCAL? How does it help in hardware abstraction? MCAL is a layer in the base software that provides the interface between the microcontroller hardware and the software stack. It abstract the specific microcontroller hardware detail from upper software layer, enable the application other ports of software to remain independent of the hardware platform. Functions of MCAL includes peripheral devices. It is used to access the internal microcontroller peripherals like timers, ADC, PWMs, and communication module. Memory management, it includes the internal memory, where it includes the flash and RAM. Low-level IOs, handling of the low-level IOs, operations such as GPIOs, communication interfaces, and other basics hardware controls. By abstracting this detail, MCAL make it easier to port the software to the different microcontroller architecture, improving code, reuse, and flexibility. Can you explain the difference between MCAL and the ECU abstraction layer? MCAL is used for internal microcontroller peripherals, while the ECU AL is responsible for abstracting the external hardware peripherals and devices. What is a client service communication executed in AUTOSAR? The client port makes a service request. The RT runtime environment routing that request to the service port. The service port processes the request and returns a response. The client port receives the response. The client server communication can be synchronous. Client wait for the response before continuing.